First, does anybody want to get up here and do yeah, I'm really excited to be here to talk to you about a couple projects we just wrapped up, looking at how restoration could affect the balance between reef growth and reef erosion processes in the Florida Keys. And I know I don't have to convince anyone in this room that there's a lot of reasons that we need to preserve reef functions. All of these habitat variables that reefs support have a huge contribution to global economies in the U.S. alone, predicted to contribute about $2.1 billion. If we consider the additional function that reefs can provide in shoreline protection, that value is nearly doubled. Again, I know I'm preaching to the choir here, but the point I really want to make is that all of those important ecosystem services don't just rely on that veneer of living coral that's at the reef surface. What really provides the literal foundation for all of those ecosystem services is the growth and maintenance of that geologic structure that's built over hundreds to thousands of years. And that's why understanding and quantifying that reef growth process and how restoration might affect it is so, so important. So there's a couple different ways that we can measure reef growth. First, we can get empirical estimates of reef growth over hundreds of thousands of years by coring into these reefs. These geologic records can provide really important baseline information that gives us context for interpreting more recent trends, but they can't tell us about the very recent past, they can't tell us what the present state is of that reef growth process, and they can't really tell us about what's going to happen in the future. For that, we've been using carbonate budgets, and carbonate budgets use commonly available reef survey data, the sort of data that's collected in a lot of reef monitoring programs, to estimate the balance between reef growth and reef bioerosion. So on the positive side of the carbonate budget equation, you have carbonate production, which is simply a function of how many calcifying organisms are out there on the reef and how fast they grow. The negative side of the equation, we have all the organisms that break down that reef structure over time. We would expect that on a healthy coral reef, carbonate production would outweigh bioerosion, and so over the long term, you would have reef growth. On the other hand, we know a lot of our reefs don't look like that really pretty picture that I showed you, and as reefs degrade, bioerosion can become the dominant process, and we'll lose that structure, again, that was built over hundreds to thousands of years. An important caveat here is that carbonate budgets don't estimate all of the different erosive processes. They really only give an estimate of bioerosion. So they're probably a high-end estimate of reef growth potential. But I think they're a really powerful tool that could be used by this community because it's a way that we can quantify in real time a process that can really only be measured empirically over these geologic timescales. So we just wrapped up almost a decade of work looking at coral growth reef growth in the Florida Keys. First, we have geologic records that we've used to measure reef growth over hundreds to thousands of years, all throughout the Florida Reef Tract. We recently completed a series of carbonate budget reconstructions using sites monitored annually by the Coral Reef Evaluation and Monitoring Project. So we looked at 49 sites from 1996 to 2019 to look at historic changes in this reef growth process, using data on benthic cover, urchins, and sponges from crimp, combining that with parrotfish data from the Rapid Visual Census program to do those historic reconstructions. And then the last piece of this study was to look at how these processes could change in the future. So we used information on restored coral cover targets at 3 of the sites in this study from Mission Iconic Reefs. So pay attention on this slide because I'm going to tell you everything that we've learned about the growth of reefs in the Florida Keys, past, present, and future, all on one slide. So first, the long-term history of reef growth in the Florida Keys. What you can see right away is that unlike many Western Atlantic reefs that grew relatively continuously until very recently, Florida's reef growth has been declining for a very, very long time. And they really only grew on par with other Western Atlantic reefs around 7,000 years ago. We hypothesize that this is because the subtropical environments in South Florida, as the regional climate changed, became less and less like these more tropical environments in the Caribbean, and therefore less and less favorable for this reef growth process. But we also found that these reefs were not yet eroding. They were more or less maintaining that structure, not until more recently. So now looking at the carbonate budgets, and just to orient you in this upper plot, reds are going to represent reef erosion and blues are going to represent reef growth. So in these, you can again see that there's been a declining trend over time, whereas in 1996, you see relatively high reef growth potential. That's declined over time at most of the sites to the point where we estimated that as many as 85% of sites throughout the reef tract are now eroding faster than they're growing. So we're rapidly losing that structure, and this puts Florida's reefs at a pretty dire place. But the really exciting part, I think, about this study is that we also showed, oh, I skipped a whole part. Why did they decline? So we showed that this had to do with the loss of particularly two key reef-building species, Acropora palmata and Orbicella species, as a result of thermal stress events and disease. Really interesting, and this also drove relative increases in more weedy or stress-tolerant species like Psittacea, which don't grow as fast, therefore don't contribute as much to reef building as these species that they replaced. A really interesting thing is that if you compare the composition of modern reefs to what that geologic framework was built by over the last 8,000 years, you can see that it looks very different. The loss of these key reef-building species and the increase in the relative abundance of these weedy or stress-tolerant species is unprecedented over a millennial timescale. But now we get to the good news. So we used the specific coral cover targets for 3 of the taxa included in Mission Iconic Reefs for those 3 sites. And what we showed is that for those locations, reef growth could potentially be restored to levels we haven't seen for 7,000 years. This would allow the reefs potentially to keep pace with present-day rates of sea level rise and come closer to keeping up with rates of future sea level rise. So this is a really exciting possibility for these reefs. And if reefs have the potential to keep pace with sea level rise, there's also the potential for reefs to help maintain, or for reefs to maintain their role in coastal hazards protection. And we evaluated this possibility with a study we just wrapped up at Buck Island Reef National Monument. It's off the north shore of St. Croix in the U.S. Virgin Islands, where that star is there. Again, in this plot, reef growth is represented by the blue colors. The more warm colors are reef erosion. What you can see looking at all these sites that we studied is that the vast majority of the reef at Buck Island, like the vast majority of the Florida reef tract, is eroding. But we did find something interesting. The southern reef crest at the time of our study was still dominated by Acropora palmata, and therefore these sites were at least maintaining elevation at present. And this is really important because we know that this is the most important habitat for wave breaking, and therefore the habitat that's most likely to provide coastal protection. We also know that sea level rise is going to increase coastal flooding no matter what. This is the results from a hydrodynamic model that we developed for Buck Island with sea level rise scenarios of 0 meters in the inner band out to 2 meters of sea level rise in the outer band, warmer colors representing more coastal flooding potential. But the other thing that we were able to do by projecting the changes in bathymetry based on these carbonate budgets is we were able to compare what that northern part of the reef that's eroding versus the southern part of the reef that's maintaining its elevation looks like in terms of these coastal hazards. And what you can see is that reef erosion is predicted to cause more extreme coastal flooding, represented by these darker colors in that eroding part of the reef versus the lighter colors in the southern part of the reef. And that's because you're going to have less wave breaking on these reefs as the reef gets deeper and deeper. The opposite is also true, though. If restoration can help the reef keep pace with future sea level rise, then some of the most significant impacts of these coastal hazards as sea level rises could be mitigated. So we investigated this possibility again at Buck Island using a similar method to what we did in Florida. In this case, we used restoration targets specifically for that reef crest habitat, so Acropora palmata. And this is what we found. So this is increase in Acropora cover on the x-axis, and then projected elevation change to the end of the century. And what we found is that, as predicted, without any mitigation, this reef is going to continue to erode. Coastal hazards are going to get worse. If we can have some sort of moderate restoration, the reef will begin to grow. But with high levels of restoration, we found at least 25 to 30% increases in Acropora palmata cover. The reef would be able to keep pace with low to intermediate scenarios of sea level rise predicted by the end of the century. And this is really important because this means that that wave-breaking function that we have today could be maintained under those sea level scenarios. Everybody's probably wondering, can we actually achieve plus 30% coral cover? We did some very first order models, population models, to estimate what it would take to get to that level of coral cover increase, using data that we collected over the last 2 years on the growth of Acropora palmata around this island. The good news is we know the species grows really fast. So what we were able to estimate is that if these corals could be outplanted at a density of about 3 individuals per meter squared by the end of the decade, a single kind of restoration effort, we could maintain high coral cover around 25% or so to the end of the century. This is even in the absence of sexual reproduction, but our model does assume some acclimatization to some stressors over time. So the biggest takeaway for me from these projects is that there is hope for restoration to reverse long-term declines in reef growth, restore this key reef function, potentially bringing growth rates to levels that we saw historically in some key areas, allowing these reefs to keep pace with maybe moderate rates of sea level rise projected for the end of the century, and therefore mitigating some of the most extreme coastal hazards that we're likely to see during storms. One key point, though, that I want to make is that restoration will be most successful if we focus on species that build reefs in the long term. Probably didn't notice because I went through it super fast, but that pie chart that I showed you of the geologic record of reefs in the Florida Keys, you may or may not have noticed there was no Acropora cervicornis, or almost no. I think it was about 1%. So that species often doesn't build that same sort of lasting reef structure that palmata and these massive corals do. So finally, last point, because I know I'm out of time, I just want to emphasize that all of this research, I think, provides some really exciting information on how that reef growth process could be affected in theory, but it's really important that we start doing these measurements to see how restoration is affecting it in practice. And that's something that we're working on now, so maybe by next Reef Futures. Thank you. And I'll thank all my students. I'll leave that up.
We have time for 1 or 2 questions while we're transitioning speakers. Any questions for them? Yeah.
Yeah, great talk. On the size of the footprint.